Hi there. I just wanted to discuss with you this theory called integration by parts. Now, I've written down this formula, but this is not integration by parts formula. I just wanted to warn you. This is the product rule. The product rule. If you didn't know it, you should know it because I'm going to use it now to derive the formula for integration by parts. Now, I assume that you know this, so let's proceed. What I can do is I can multiply both sides by dx, so I'll get rid of these dx's. So next step will be d of u times v is equal to du times v plus dv times u. Alright, now I'm going to integrate both sides. This is a fairly common operator. I'm going to integrate both sides. Alright, so in the previous videos I told you that the integral of d of something is that something. So this becomes u times v, and if you remember the property of integral that if there's an integral of a summation, then you can individually integrate those and sum them up. So this is nothing but the integration of du times v plus the integral of dv times u. Okay, let's simplify this further. This is u times v equals. Now, I'm just going to leave it this way. Just going to rearrange this. Integral of u dv. Alright. Now I'm just going to subtract this term right here. This term. Let's just subtract it from both sides. So we get that the integral of u dv is uv minus the integral of v du. That's pretty much it. This is the integration by parts formula. I don't want you to remember this because it's just kind of a aperture of the product rule, so you can derive it anytime. So that doesn't seem very interesting, right? So let's just do an example using this. Let's just do a quick example doing this. Alright, let's do it. So that's not what I wanted to do. So I want to integrate x sin x. Oh my goodness, you'll say, oh my goodness, how will I do this? Well, this is the formula right here. We can use it. But I want to tell you that u and v are two different functions, right? So it's just the product of two different functions. Now, if you carefully look at this formula, you need to integrate the second function. If I call this the second function and this as my first function, you can see that later on in the formula I'll have to integrate the second function and I'll have to differentiate the first function. So in this example, you should choose the function which as the first function, which when differentiated becomes a lot simpler. Now, if you choose sin x as your first function, its derivative is cosine of x. Well, that doesn't seem any easier, I guess. But look at this, x, beautiful x. When differentiated, this becomes a 1. Now, I guess 1 is the most easy that you'll get ever. Most easy function, I guess. So I'll pick this as my first function, or u, yeah, as I guess. And sin x dx, the whole thing as the second function, or just as dv. So I'll just apply this formula. So it tells me that this becomes, u remains the same, that is x times, says I'll have to integrate, right? Integral of dv is v, so I'll have to integrate sine of x. And then it says that I have to subtract the integral of v, which is, I guess I'll have to differentiate it. It's a little messy. You can do this in your head if you want. It's just for educational purposes. Okay, this is the integral of v, which is integral of sine of x times du. Now du is the differential of x, which is 1, non-differential differentiation. Something. Okay, so that's times 1. So you can see that this becomes the integral of sine of x, if you remember, is negative cosine of x. So this becomes minus x cosine of x minus the integral of sine of x, well, that is negative sine of x. I can take the negative out, so this becomes a plus, and this becomes the integral of cosine of x. And of course we have a plus c here. So this becomes what? Minus x cosine of x. The integral of cosine of x is sine of x. Sine of x plus c. There you go. We have integrated this hairy looking, pretty daunting function. Well, that's integration by parts for you. It's sometimes useful, sometimes not. You have to carefully choose your first and second functions. If you don't, believe me, you will get nowhere. So I guess that this helps you as well as me, because I'm going to do some problems coming up. So I guess that's it. Thanks.